welcome back to another video. Today I want to look at the derivative of e raised to x from the definition of the derivatives. So when function of x, we want to look at the derivative of e raised to x. So from the definition of the derivatives, let's go here, solution. But in case you're watching us for the very first time, please subscribe to this channel. That is the only way you can support us. So without any further ado, let's dive in here. So let's look at, from the definition, we know that as the limit h is tending to be 0, then function of x plus h minus the function of x over h. That is the definition of all the derivatives. So can we now just replace here, there? So as the limit h is tending to be 0, then e raised to x plus h minus fx, which is our ex, then we are dividing by h. I hope we are together, you guys. I hope you're following. Then I want to apply the law of indices here. I want to break this one out so that I have, as the limit h is tending to be 0, then e raised to x dot multiplied by e raised to h minus e raised to x. This one is all over h. That means all over h. But I can see the e raised to x is common here. So can we open up the bracket by e raised to x? So as the limit h is tending to be 0, then e raised to x is equal to e into bracket e raised to h minus 1. And this one is over h. I hope we are together. But now, there's something here that we know that the derivative of e raised to x, I know you've done it before, and you know the derivative of e raised to x is equal to e raised to x. So that means that this part here, which is e raised to h minus 1 over h, is equal to 1. We want to see how that one is equal to 1. So let me take e raised to x. Let me just deal with this part alone, just down here. So let me pick e raised to h minus 1, and let me equate this one to be equal to n. Equal to n. So that means that e raised to h is equal to 1 plus n. You see? Then I have an exponent here raised to h, e raised to h. I want to take the ln of both sides, the log of both sides. So I'll say that h ln of e is equal to ln of 1 plus n. You see me now? Yes, something is coming. So the natural log of e is 1. I hope you know that ln of e is 1. So we have h into 1 is equal to ln of 1 plus n. Then that means that we have h is equal to ln of 1 plus n. So I want us now, we have now that is our h. We want now to replace back. So can we go the other side? So as the limit, so my limit now, I won't be taking as the limit h, but now I have my n. So I'll be taking as limit of n. So as the limit n is tending to be 0, then we have, because we left ex there, so we have ex dot. So can we now replace? Can we now replace back? So we have e raised to h minus 1, which was our n here, as you can see. So that one we have n over h, and our h is natural log of 1 plus n. 1 plus n. Remember, the limit is outside bracket. So what I want to do, I want to flip this one. I want to flip so that we have as the limit, as the limit to be 0, then we have the e raised to x dot. So this is 1 over natural log of 1 plus n over n. So this means that when I take the 1 over the reciprocal, then I'll still have my initial value, which is n over the natural log of 1 plus n. But now I want to take this n outside so that I have as the limit n is tending to be 0. We have ex dot 1 over 1 over n, take this one outside, ln of 1 plus n. And again, I know the law of logs that if you have the product of a value here, I can put it there so that it becomes the exponent of that if you apply the law of logs. So as the limit n is tending to be 0, so we have ex dot 1 over ln of 1 plus n raised to 1 over n. There's something which is coming. I hope you can see me. You can see me. There's something which is approaching, and you can see e is coming from somewhere else. Now, I want to talk about when the definition of e, here we have the two definitions of e. E is equal to, let's just define e here in two definitions. We e as the n tending to be infinity. Then we have 1 plus 1 over n raised to n. And another one, as that n is tending to be infinity, then we have 1 plus n over 1 over n. So this and that are the same. So you can either define it this way or this way. But now we are busy with this one. That is the one because that is it resembles whatever we have there. So we know that this one is e. So can we now take the limit of both sides? So we know here that the product of the limit is the limit of the product. The product of the limit is the limit of the product. So we have as the limit n is tending to be 0. So we have ex as the limit n is tending to be 0. Then we have 1 over natural log of 1 plus n raised to 1 over n. Then we also know the division of the limit is the limit of the divisions. So also as the limit n is tending to be 0 of ex multiplied by the limit up there, limit n is tending to be 0, 1 over as the limit of n is tending to be 0 of natural log of 1 plus n raised to 1 over n. Also this one you can take the limit of ln outside is equal to ln of whatever in the bracket, but we know whatever in the bracket here is e. So can we now take our limits? So this one it doesn't contain any n in it, so that is just e raised to x multiply, this is a constant, 1 is a constant, and that one now we just have 1 over as the limit tending to be 0. We've seen this is our e, so that is we have the ln of e. Why, it's very sweet, you guys. Mathematics is very sweet, and there's something which is coming. So let me ask you a question. What is the natural log of e? The natural log of e is 1, because we know that when you have the natural log of e, this one simply means the log of e to base e, and the log of a number to the same base is 1. So this one we have ex dot 1 over 1. So we have that ex multiplied by 1, and we get it to be ex, you guys. So the derivative of e raised to x is equal to e raised to x. Mission is accomplish. You guys, if you've learned something, make sure you give this video a thumbs up. Never stop learning, because those who stop learning stop living. Bye bye.